I hope you enjoyed the lunch and also the sun outside and had the possibility to network with the other participants. Before we start with our afternoon program, I would like to ask those who have chosen the usability test not to forget to go there and make the usability test. You should have in your name tag the time schedule. If you have chosen the usability test, you have information in your name tag. Okay, now we want to start with our partner presentation this afternoon, and we are starting with a very exciting water project in the Netherlands, realized by our partner Kroonwater and Dros. And they are a long-time WinCC OA partner and brought a long-term SCADA experience into the project called PASSI, which made it such a success. Please welcome one of the main actors in this project, Mr. Remco Derenberg.
So, hello everybody. My name is Remco Derenberg, like she told you already. And I work as a sales consultant for Kroonwater and Dros. Well, I'm pleased to present a very interesting project that we developed. We realized that in combination with waterboard Scheldestromen. But before I will go into detail, I will just introduce both companies. And first, I like to start with waterboard Scheldestromen. Well, the waterboard Scheldestromen. You will see some nice things over here about waterboard Scheldestromen. Their work is very important. They make sure we keep dry feet. They make sure that every day you flush your water and everything through a whole system of ditches and creeks. They process the whole water and make sure we can nicely save and live in our environment. Over here on this picture you will see, well, some processing about it. And that's actually what they do. They're active in the southwest of the Netherlands and that area called Zeeland. Well, next introduction is about my own company, Kroonwater and Dros. And well, it's easy because I don't have to talk with this one. Works.
Us humans are getting increasingly more intelligent. This has been proven. And the good thing is, so is our living environment. Buildings, tunnels, industrial property, and ships. Smart systems and technology enable them to think, make their own decisions, respond to situations, and even intervene. A fantastic development started and boosted in the Netherlands by Kroonwater and Dros, the company that unites electrical engineering, automation, information services, and mechanical engineering and allows these disciplines to work together. That's good for our clients and for the world around us, which we make increasingly more intelligent through technology, so that office buildings know how to boost our desire to work. Hospitals help us recover. Roads and tunnels ensure our safety. Industrial property makes itself more efficient. And even vessels know how to navigate independently. More intelligence in everything that's built means increased safety, more comfort, sustainability, efficiency, and increased productivity. Kroonwater and Dros, for intelligence through technology.
Well, that was a short introduction of both the companies. Well, if we're talking about Kroonwater and Dros, like I said before, we are an independent system integrator, and we have a long history of using Siemens products. And if we're talking about WinCC OA, we realized many projects already. And of course, that's what we're here for, talk about WinCC OA. One project that I picked to show you here is the project PASSI. PASSI in Dutch stands for passion. And of course for passion fruit, that's on the logo as well. But in this map over here, you will see a geographical overview of the southwest of Holland. We call that Zeeland. that is the area that our customer is responsible for. This whole project took us about 2 years. It started in June 2013, all the way up to June 2015. Over here, you will see the WinCC OA interface that we built for them. It's just an overview. You will see a little bit more about that later. Here on this map, you will see that same geographical overview, and on the map you see all kind of round dots, 9 of them. In the time of period, we just replaced 9 purification plants and 100 pumping stations with the square dots you see on the map. During this project, we replaced the total old process automation system for them, which included the SCADA system to WinCC OA. What we did is we centralized the whole visualization system on one spot. But all the 9 locations over here are still independent because they run on a redundant server. We use all kinds of techniques to make that possible and to synchronize the data. One of them is DIST. Some people know that. Single point of configuration is the technique that we call. Let's see if I covered everything. During the implementation phase of this project, we used also a really advanced document control system. The document control system, or actually the version control system, made it possible that we just planned the whole situation over here in 2 years. When we started rolling out, we did about 3 to 4 pumping stations each day. It was a little bit too fast for a customer, but we were able to do it. I just spoke to him yesterday, and he said, well, actually 4 pumping stations each day was a little bit too fast for us, but we will manage to do it. So that's pretty impressive. Within this project, we developed a couple of features. And I think they're really special, because why are they special? They're special because we were able, together with the customer, looking what his needs are, and then develop a tool. Instead of just doing a technical show-off, like, okay, this is what we can manage, and this is what we can make, and this is everything. And I'd like to show you a couple of those features over here. The first one starts with the GIS viewer. What you will see over here is the geographical overview, and the whole system is actually built around this. Well, you can do this full screen, or you can zoom in on some locations to take a closer look at. The information that you like to see can be switched on and off by selecting the right layer. Like over here in the symbols, you will see all kinds of pumps and other information showing up. Other things we have are things like flow, things like pressure, and all kinds of other things. So depending on your needs, you can just switch the different layer on and off on the geographical overview. Well, here you have selected the whole area again. And in case if you just want to zoom into one of those other areas, you just take a marker box, you go around it, and then you will see the icons pop up with all the information. Like here, you can see there's something like maintenance going on, and there's somebody available at site. Well, if you're at a central location, it can be very helpful to know what's going on. Well, this whole geographical overview can also be part of the multi-screen mode. There are 4 screens over here, and this can be one part of it. And you can just select which one. Well, imagine that you're an operator and you're responsible for a part, or you want to zoom into a different part of your work area. Well, you can just select the window and just click on the map, and then it will switch over to the process map you desire. And in this case, you will see another one. You click on it, and you will see the map. Well, this is of course very helpful for an operator, because it feels natural, it's flexible, you can put it everywhere you want. And another interesting detail about the GIS viewer is that the old maps in the old system are just reintegrated into this system. Well, another thing, we're talking about a water chain over here. But this water chain is divided in two parts. You have the municipality on one hand and the water board, the one that we work together with. But they're totally dependent from each other. Because when water comes, in case of a rainfall, the water board needs to process the water. Of course, because they're connected to each other, as you can see here on this small overview. Most of the time, that's a little bit of a problem, because in a water board you have also something like maintenance. You need to shut down. You have, and on the other hand, there's something like buffer capacity. You can just wait till you give your water all the way up. But you need to work together very closely to make this happen. Well, this was always a challenge. Before we started this project, we found already there's a challenge between them, because one has needs, the other one needs to do what the other tells you. You have buffer capacity, you have maintenance. There's all kind of things that still have to discuss together. Up till now, of course. Because within the system, we made possible, in our system and at system of the municipality, we made possible that they can look into each other's systems. They can see if there's buffer capacity, if it's possible to wait a little bit, or just, okay, there's a lot of water coming, it's not the right time to do maintenance or to shut down, or those kind of things. Well, there's a technique we used, we call that soap. You write it the same way as the soap you use to wash your face, I believe, but that's the technique we used. And that way we made sure that there's a lot better cooperation between the two. Well, it's another technical thing that we just implemented to make possible that the two work much better together now. Everything is based on real-time information. And this way they're not crossing each other's path anymore these days. Well, something about trending. Well, we saw a little bit about trending earlier already. The new one, this is a little bit the ones we see today at our customers. Well, the good thing about this trend is, first you can be free at hand. You can do whatever you want. Select your pens, colors, you can scale, you can put it at a position you like. And of course, you can blow up the whole screen again if you want to take a closer look. But on the other hand, we also have something like predefined tags that you see in the tree over here. You just go over there and you select your trend tag, and then you have the trends that, well, normally you will use in the daily life. Well, you put them in the right order. But on the other hand, we also have like the object menus. Over here you will see an object menu popping up. In the object menu you can also just get your trend information about this object. And if that's still not enough for you, you can also drag and drop, like in this case a valve, into here, select your color, and there you go. Open and close moments of the valve, or a transmitter. Well, drag and drop functionality, you can put it in every trend screen, whatever you like, from every process screen you want. Well, yet another example, I believe, to see which, where you can see that the technique is helping the operator. I was actually a little bit surprised. Everybody think, oh, he's surprised, but I will explain, because at the end I was having a nice picture, and I was, hey, where's my nice picture? So, and that's the surprise. That was on my face. Okay, let's see if we covered everything. Another thing about trends. We saw these beautiful trends that we built, of course. And over here, trend alarm. Well, imagine you have something like a problem. You discovered a problem with a pump. Well, you see a trend over here, and just you figured now, okay, there was a problem. Which day was it? I will go back to the day my problem occurred. Well, I will select it here, click, there you go. Well, we have the trend information now from the object we like to investigate. Under the time and date ruler, you will see when the alarm occurred and when it's accepted by two small icons over here. Well, the tooltip will give you extra information about the trend we are talking about. This is really easy if you're trying to discover a problem. Well, over here you have the lines we saw earlier, but these are the, well, a little bit the old lines, because we're not at the new version here yet. That has to come. But over here you will see all the data from the line 1 and line 2 spread out together, so you can just make your analysis and just find your problem and see what's going on over here. I think that's another great feature that you can just use in your daily life if you're an operator of a plant like this. Okay, there's still a little bit more that we added. Imagine you have that problem with that same pump. And you have some co-workers that you like to inform, okay, there is something going on. And you put a post-it memo on the keyboard. Of course, it's not going to work in this bigger area with so many locations. So we find out we need to have a digital memo. Well, over here you see how it looks. It looks a little bit like a post-it memo even. But you can just open the object menu and just type in whatever you like to share. But that's not everything. It's in the object, but also on the icon itself. Like over here, you will see, hey, there's a pump. Somebody put a post-it memo on it. Like everybody in the whole area can just see, okay, there's a post-it memo placed. Who placed it and what is going on? Another thing is it will pop up in the total list of messages. Well, total list of messages, easy for your shift change. If you're doing a shift change with your co-worker, you just go over him and you say, hey, those are all the things that we managed. And over here in the trend page, again, it will pop up in the bottom next to like an alarm or like an accepted alarm. You will find also your post-it memos in the trend. Again. I don't know why, but. Okay, let's see if we covered the whole thing. Well, this was something about the logbook that we just built for this customer. Well, another really interesting thing that we built for him is I told you about the 9 purification plants that we just did a revamp on. And we had 100 pumping stations. Well, 100 pumping stations were all locally spread out in this area, Zeeland. And they were all equipped with a local panel. Because if you go over there for maintenance or anything, you need to see something, you have to operate something, you have to do something. Well, all those 100 local panels gives you a lot of problems. You have to update them, you have to go over there, maybe they break, maybe somebody will steal them. All kind of reasons to put them in there. And actually, 100 local panels cost a lot of money. So we discovered there's a way to do it a little bit better. You can also do it with an iPad. So what we did, we ran a pilot and we built both solutions. A local panel and what you see over here, the iPad version. So all the pumping stations are made blind. Well, blind, you will see no panel anymore. And we gave all the operators, all the technicians, we gave them an iPad so they can just run over the area, log into the system and see what's going on. And we let them tell us what they found the best solution. Well, and of course, it's easier to maintain, but for an operator, well, theft and cybersecurity are better manageable, of course. They're more flexible to use because you don't have to go to the location. You can also do it from your home, underway, or whatever. But of course, for the operator, it's much cooler to use an iPad than a local system, of course. So that's what we did. It looks like it's a little bit advanced solution instead of local panels, but it saves them a lot of money. Well, of course. We gave that back to them, of course. But you can make all kind of nice other solutions, and you have something else to do. Well, this picture is missing as well. Well, I will send you the pictures later if you're just interested in nice overviews from this waterboard. But what I like to say is actually, well, this was a really successful project. Our customer is really satisfied with it. And what happened is, well, there are multiple waterboards in Holland, of course. And a couple of them, all WinCC OA users, sat together and just spoke to each other like, okay, what is now the best solution? Well, they figured that what we put over here comes close to a standard they want to meet. And right now we're actually just putting another waterboard on the same system. And we're just rolling it out right now. And what I believe, actually, that is the biggest compliment for the whole team that built this innovative system for the waterboard. Well, I hope I'm a little bit within the time still. Okay. I hope that everybody enjoyed this presentation, movies. Are there any questions? I hope not. Well, actually, that's a joke. But if there's no questions, I'm totally clear. But if there are questions and they're technical, I'm a little bit not the most. We have experts here in the room that I can go over. But if you have a question, go ahead, try. Well, then I thank you for your attention, and this was my presentation.
Thank you for your presentation.
Thank you very much.
If you have questions to Mr. Derenberg or all the other presenters, do not forget to use the question and answer tool in our mobile event service. Now I would like to welcome our next speakers. It's Matthias Kreppertz and Christian Rauch from Inet. They are our partner, WinCC OA partner from Austria, and they would like to present a very interesting project they did. Here we go.
Hello, ladies and gentlemen. Good afternoon. My name is Matthias Kreppertz. I'm the CEO of Inet, and this is my colleague, Christian Rauch. He is lead software engineer and the head of the project team of Inet Framework. Welcome to our presentation of Inet Framework. At first, I will give you an overview about Inet. Then Christian will explain the joint development of our customer and the main parts of the Inet framework. So the respected customer asked us to be not mentioned in this presentation by name because of confidentiality agreement. So sorry, but in the agenda there is also a name. And I hope to the end of the presentation there will be enough time for the question. He asked us last week, so or the management. Now, engineering network, Inet. The E from engineering and net for network. You will see our name is our program. And our task and our goal is to success and improve the success of our customers. Give me some background information about Inet. Inet was founded 20 years ago. We started with 4 technicians. In 1997, we are 15 employees now. We have always 5 to 10 freelancers and selected partner companies in our engineering network. So that's very important for us. We are engineering and I think we have a good and a great network. They and we are absolutely specialized in the areas of expertise. And together we can realize very large projects in relation to our company size. Inet is an Austrian company. We are located in Tulln on the Blue Danube, close to Vienna. We do comprehensive technical engineering and solutions in these areas. Electrical instrumentation and control. We make industrial IT to our topic. DCS and PCS, distributed control system, and process control system. Also infrastructure like tunnel and metro control systems. And a very big and very important thing is MES. There we have own products and solutions. They are also based on WinCC open architecture. Now I will show you some details about our experience and expertise. eNet process control and distributed control systems. That means one tool with one and the same operating philosophy. For all tasks and all subtools, all screens and programs, we want to give clear, simple, and short information to the operator. eNet has the expertise for with safety and secure the solutions in the industrial IT production fields, including all network security questions. Some keywords about project management. We are ready for FDE and GMB. We often a general contractor, and we are one contacted person in big projects. That's for the network when we do projects with other companies. And a trusted partner. Planning and EIC technology. We provided services from the electrical instrumentation over BCS, DCS to the eNet MES. And at the eNet MES, you see we have our own products, eNet Batch, eNet Route, Maps, and eNet Reports, used in the pharmaceutical and chemical environment. We also provide consulting service and support. For example, from the interface of the enterprise resource planning system, like SAP, to the launch of the whole manufacturing systems. At last, also we can help you to create tenders and MES for tenders for MES or DCS. We are very proud to be a certified system integrator and solution partner from Siemens and ETM for many years. We appreciate the customer proximity and the customer focus of ETM. We also appreciate the security that a large group, a large company such Siemens is providing, with a very fast, friendly and competent support, which ETM can still, the last 10 years, we heard before, offer us and our customers. Moreover, the short distance to ETM and to the developer of WinCC open architecture is a very important success factor for us and our customers. So, thank you for your attention. I will hand over now to Christian.
Okay, welcome ladies and gentlemen. I will now talk about the eNet framework, multiple plant integration in cooperation with our customer. I have split it up the next slides into 5 main points. The first one is the introduction, when the project starts and so on. The second one is the system design and technical highlights of the project. Then I came to a short demo video which shows how easy it is for operators and other people to implement new things to WinCC OA. Then we came to the development process. We would also take a look at how we develop the modules and how we work with this. We have a testing framework also in the background. And as last, I will talk about the benefits of the framework. Yeah, so let's start with the timeline of the project. It started in 2010 with PFSS 3.8. Currently, we are working with WinCC OA 3.13. And there is no real end of the project planned because it's constantly being expanded. So there are always some new interfaces, modules, which have to be planned and developed for the customers. So the project focus was that we find a solution for SCADA, for safety engineering, infrastructure and media supply, and building automation. So we are looking for software and we find one. We use WinCC OA, and we can say that it's a great tool to integrate all these needings to the project. So on this slide, you get an overview what we have already developed, and there are even more. First of all, we have developed an interface to CCTV, Indigo Vision. We can control it, import it, and also get the alarms of the CCTV system. Another one is the intruder detection system. Then we have the multiple fire detection system. Here we have built some interfaces to 3 different companies. We have here Siemens, Bosch, and Schrack. One other big point is the ANET S7 library. We have implemented a S7 library for the old PLCs, the 300 and 400, and also for the new generation, the 1200 and 1500 PLCs. The nice thing here is that we have modules down in the PLC, which works with our models in WinCC OA together. It is also possible to program the back-off directly from WinCC OA, so that the operator can select in the system a sensor or such things, and he just select the input of the back-off and say, okay, there is a trend on it, there is alarming. So he don't need really programming skills to implement one temperature sensor or such things. As you can see here, we have many more interfaces. It's UPC, UPS, Migra displays, emergency power integration, building automation, water supply, yeah, and even many more. There is not enough space to do all these interfaces on this slide. On this slide, you get an overview about the system design, how it is yet. We have split it up into 2 networks. On the left side, we have the operation network, and on the right side, on the emergency network. We have split it up of safety reasons, because there is no connection from the emergency network to any internet or router office network. This is really only emergency network. There are no devices in there which has a connection outside of the company. That was very important for us because of safety. Yeah, everyone knows, yeah, it's really hard to get a network 100%, 100% safe. And so we have decided to build up 2 networks. Also, the most important sensors are connected from both networks. So we have there really 2 sensors to get a better way, and also if that he cannot come into the system over the PLC network. So there are 2 different CPUs. On the top, you can see in both networks we have redundant WinCC OA server pairs. And in the operation network, we use also this technology to get a connection to some pump stations and other things. So what are the technical highlights of the project? We have around 10,000 IOs. That's not that much, but I think it's okay. We have 2 redundant server pairs. We use Oracle for long-time archiving. We have a connection to up to 25 fire detection systems, 150 back-off nodes, about 20 S7 PLCs, 20 Migra displays, and so on. The documentation is done over a website, and we use the tool Redmine. Redmine is a platform where you can use, where you can put in the information of the project and also use it as a ticketing system. If there are any bugs or you want to plan new features, you can use it for this. In the background, we have a Git versioning server for the source control system. And we have also an automatic test framework in the background, but on this I will go on the next slides. So yeah, we are here now at the demo. Now I will show how easy it is to import a new fire detection system to the WinCC OA servers. So you have to think about it that when a new fire detection systems go to the company, is planned, then let's say Siemens bring one configuration of the fire detection system, and he can export it, the Siemens, with a XML file from his configuration software, not from WinCC OA, from his own system. So let's start with the demo video. Okay. Okay, yeah. Now you can see the content of the configuration file, which was exported from the fire detection system. And this configuration file we want to put into WinCC OA. First of all, I show you that the fire detection system is missing. It's not here. We have here B20 and B24. So on the overview, you don't see it right now. So what we do now is that he starts the import wizard. He just has to select the configuration file, select the building, and then the import will be done. It will be passed to the system. We will see, okay, these are the detectors which I want to import. He can check if everything is here, everything is fine. He can also import changes. Then not all these fields will be green, they will be red, so that he sees that there are changes. And now the configuration was imported. And in the background, the panels are created automatically. So the operator has to do nothing. He has just to wait some seconds, and then he can switch over into his visualization software. We make it here manual just because of the demo, but normally the operator has it on his menu. And you will see the B23 is here. So it was totally automatically imported to the system. And as you can mention, you don't have to be a real specialized WinCC OA developer to import such a fire detection system. Yes, in the last demo, you can also say that it is also possible to control the fire detection, the fire detectors. So maybe for servers or something else, he wants to put off some detectors, that there is no alarm in the system. He can also control it from the system there. One other nice feature is the developing process. You can imagine if you have so many modules there, the developer have to do some changes on modules. So what would happen? He will do some changes to the system, save it, and if everything looks fine for him, he can test it manually. We have a testing algorithm in the background, also for testing manually. But if he wants to commit it or send it to the server, he just has to do a commit. That's from source control systems. You commit something, and with Git you can push it to the server. And if it comes on the server, then the server automatically tests all the modules that are in the system in the background. And afterwards, he gives him the results back to the developer. So he can decide if he wants to merge his changes to the production environment, or otherwise he has to improve his development and do the test again. So for this technology, we use Jenkins. Jenkins runs on Linux, and all the process is really done complete automatically in the background. So what are the benefits of the INET framework? As I mentioned, scalability, flexibility. You have a modern architecture from WinCC OA. You can create panels automatically in the background if you want. Also, adjustments to the WinCC OA core systems are possible. You have one solution for SCADA and PLC if you use the right modules. And also, Technican can expect the system without detailed knowledge of WinCC OA. I think that's a big point because many companies have people there who needs to add a new detector or something like, and they don't have the knowledge of WinCC OA. But with our system, they can add one sensor to the system. And as we have seen on the last point, we have only validated modules in the production environment. So this was our short introduction in the WinCC ENET framework. Thank you very much for your attention. Are there any questions?
So, Christian, what is the benefit of our customers when we look before we take the ENET framework and such now?
Yeah, I think the benefit is that it's really easy to add modules also for not so trained WinCC OA employees.
And I also think for the timeline there's a big difference. Before, you need maybe 2 technicians on the PLC, and in the WinCC OA it's do it 1, and it's automatically, we are much faster than before. So I think there are a lot of benefits, and it's tested, it's validated models, and I think every engineer, every technician knows if you bring new objects in a software, there you're forgetting some point, you're forgetting something, and there we can say no, it's tested, we put it inside and will work, and I think that's a very big benefit.
Yeah, on this point, maybe can say some other things. Also, it is possible to test an upgrade of WinCC OA or update. If we have a new patch, we just put it on our testing environment and say, okay, let's start the test, and we see if the modules also work with the new version, maybe 3.16. And this is the real big benefit if you want to upgrade our solution, because you really can test all modules, each function is tested, and you get a really quick overview if it works fine or if there are any problems.
And another important thing is, in the production area of our customers, he take it like a class HMI system, a SCADA system, and the same system will work for the infrastructure, and so he have one tool for a really big area of, yeah.
Okay, enough from us. Are there any questions out there? Yes? Yeah. We are working on it to have an automatical way to deploy it to the servers, but now we make it manually. Now we decide, okay, now we want to pull, this is also from Git and versioning, we pull it from the server down to the production environment. So now it's manual, but we are working on it to get an automatical solution. If we decide everything is fine, just update the server automatically in the background. It depends really on the features, and also it depends on if we have found some hidden features, let's call it this way. And if the hidden feature is big enough, we can do it really quick, but normally about once in a month, 2 months. And the software update is normally about 1.5 years. We plan a big software versioning update. You're welcome. Yes? No, I have no data here, but what can I say? The thing is, most of these models are not really yet in production environment, because a fire detection system And CCTV also is not really, does not improve a production. It's just the background that everything works, and also the production thing can work. So the most parts of the models are not in the production environment, they are just around of them.
The difference.
Yeah, okay, I understand. Yeah, we have reduced the time. I don't have slides here to show it to you, but yeah, we have reduced the time because that's a simple thing why we have reduced the time. Because normally, when an error comes up in the night shift, there is an engineer which has no detailed knowledge of WinCC OA, and he has no detailed knowledge of the S7 library really in the underground. So with our system, he can engineer everything in WinCC OA just with a wizard. He can disable alarm, he can enable it, he can change some IP addresses, and all these things are done over wizards. So now he can do these changes, and so he can improve the time to get it fixed. Okay. Yeah. Yeah. Okay, that's a good question. No, I think we have to talk later on outside, then we will find a way. Okay. Okay, thank you.
Thank you.
Thank you, Matthias and Christian, for this interesting project presentation. I think we have to go on. The next speaker is already on stage. It's Mr. Cornelissen from Altron, and he will show us the solution with WinCC OA for simulation, for test and design of industrial automation. Please welcome him on stage.
Thank you. All right, before we start, I probably have a little bit of a different presentation than our previous speakers. First of all, I don't have any paper, so I have to do it what I see on the screen myself as well. And I also don't have these nice videos, but I hope my story is in any case interesting enough for you to listen to it before we go to the break. First of all, my name is Ferdinand Cornelissen. I'm from a company called Altron, and Altron is a large engineering and research and development company, a global company, 35,000 people worldwide, approximately 1,000 people in the Netherlands, doing all kinds of stuff on software development for technical automation, industrial automation, and consultancy. Now we have that out of the way, because I also do not want to talk too much about Altron, because I'm actually also here because of the company OpenEye, which is a special purpose company, which is put together and has only one task, that is to build the largest C-lock in the world, and has started developing this. Also a C-lock, maybe nobody exactly knows what a C-lock is, or a lock. A lock is not something on your door, well, it's also something on your door. But in this case, a lock is used to actually move vessels from, for instance, the sea into the canal, towards Amsterdam. In IJmuiden we have a complex with many locks, which are being very important for the harbor of Amsterdam. If you look close to the central station, there's a cruise terminal, and these big cruises that are lying there and put all these tourists maybe for fun here in Amsterdam. These cruises are coming via IJmuiden through one of these locks that are over there. And although there's already a very big lock there that can actually move these vessels from the sea to Amsterdam and vice versa when they move away again, it's actually not big enough, so we have to build something bigger. The OpenEye is a company that's actually built up from two main contractors, which is BAM and Volker Wessels. They are the main contracting partners. with a lot of technical partners that provide the technical and all the expertise that is needed to design, build, and eventually also maintain this new lock that's being built. And Altran is one of these companies, and that's what my role is also here. OpenEye, this was also a very special contract because it's one of the what we call design, build, finance, and maintain contracts. We'd have a very large time span because we also had to factor in the the maintenance of the C-lock for the next 27, say 30 years. And this is also has to be taken into account during the design and development of the C-lock. It's also important to mention, I think, that the one that gave us the assignment, our customer is basically consists of many different bodies, so to say. We have Rijkswaterstaat, of course, but also we have the Port Authority of Amsterdam. We have Velze, which is one of the stakeholders. So we have many different stakeholders that all want to have their C-lock in such a way that they can actually operate it correctly and that they can use it correctly and that it will provide the services that they request from us. So maybe a couple of numbers to actually explain what the C-lock actually is. So there is a pointer on this thing, I guess. Maybe this one. I hope I don't switch it off. Ah, that's good. All right. So this is IJmuiden. You see here a couple of the locks that are already there. This is the northern lock. You got the Middensluis, which is in the middle. The southern Zuidersluis, which is in the southern part of IJmuiden. And here you see that is actually a wish for a new, bigger C-lock. The currently biggest C-lock is the one on the Noordersluis, the one on the north of the newly built lock, which is now 400 meters, approximately 50 meters wide and 50 meters wide, 15 meters deep. And what we eventually will have, and I say eventually because it's not built yet, is a lock which is 500 meters long. And this is what makes it very big. It's 70 meters wide, and this is very, very, very large. And 18 meters deep. So we can have even bigger ships getting towards Amsterdam. The 18 meters deep means that you can have, of course, vessels that are a little bit deeper into the water. Let's see. Well, maybe for those that still not have an idea what a lock is. A lock actually, I mean, if you have different water levels on the sea and on the canal going into our mainland, you have to somehow elevate or lift or drop, so to say, the vessels to continue on. So basically what a lock is like a big elevator for vessels. Basically that's what it is. You put your ship in, you lower it or heighten it, and then you move it on towards the next, after the lock. And of course this goes with doors, and these doors have to be operated correctly, and there have to be a lot of safety measurements that we don't open up the doors on the same time. And all this stuff has to be put into our PLC SCADA system. All right. A little bit more of, well, these are nice pictures, at least these are good. This is the current situation. You have here the northern lock. This is the middle lock. And well, this is a large ship. I'm not exactly sure if it fits, but it will fit narrowly. That's usually how it works now. It fits narrowly. But it could also be that it's a little bit of an illusion that we're looking at here. Anyways, this is the current situation. This is the projected situation from our customer. So that means that, well, they have something like a big highway all the way to Amsterdam. By the way, we're looking at the sea at this moment. For those that know the area, this is Tata Steel. There's a lot of PLC SCADA stuff over there as well, by the way. Probably Siemens, I don't know. This is the Tata Steel. This is actually IJmuiden, and Amsterdam is, well, here actually. Well, we're in Amsterdam, so that fits. And this is the projected situation. And what we're building at this moment is actually this situation, where we have a nice lock which has this dimensions that I just mentioned earlier, and we predict that it will be finished in 2019. That means also that we are still not, that it's not finished. I mean, the previous projects were all finished products. At this moment, we don't have a finished product at this situation. But one of the things that is very important to realize is that industrial automation, or the automation solution that you're using, usually follows very late in the project. And that means that all kinds of problems and risks in integrating the software and this kind of stuff happens also very late in the project. And this is something we want to prevent, because if you have a delay, it will cost you a lot of money. And we don't want this. And of course, we don't want to have the blame on industrial automation. At least that's what I hope. The system itself, I mean, this is just a couple of pictures of the systems that are inside this lock. If you look from an industrial automation perspective, it's not a very complex thing. I mean, it's got a barrier or a couple of barriers. It's got some signals and lights, and it's got a CCTV as well. And there's a little bit more there, of course, to drive also the doors, which are quite large. So there's quite some stuff in there, but it's not as complex. I mean, we're not talking about 20,000 I/O or something like that. I mean, it's more in the order of magnitude between 3, 4, maybe 5,000 I/O. So it's not very big, and even that's very, very low. But still, I mean, because it's very diverse kind of subsystems that we're driving and sensing from, and many disciplines that are working together, it makes it, from a project point of view, quite difficult, to be honest. And what we say, what our design philosophy actually is to use simulation as much as possible to validate our decisions, to validate our design decisions, to make sure that what we build is actually what is expected by the customer, and that we build something that can be accepted early on and first time right, to be honest, the moment it's being delivered to the customer. And this is a very general view of what systems engineering is actually about. I mean, it's you start off with a concept, you go into a design phase, a production phase, integration, and eventually it's in operation. I think every system is built like that. But there's different kind of focus that you have if you look at trying to figure out how can we minimize and reduce risks related to industrial automation. The first is that in the first phase, in this concept and design phase, communication is essential. I mean, it's very important to have a good and clear understanding of all the requirements that we have to take into consideration when we design and build the system. But these requirements usually have quite a large history. In this kind of projects, there's public infrastructure projects, there's usually quite a history behind before the projects actually started. And that means that all these requirements need to be validated again, and sometimes you don't know where they're coming from, but it's good to have these clear in view. When you start designing and going into production and pre-integrate stuff, then you really would like to test if your software is working, if your components are working correctly, if the components follow the interfaces, especially if you have different suppliers, where you actually define the interface, and these suppliers have to provide the components implemented according to these interfaces. Then you want to be sure to actually pre-accept or do an acceptance of this component before you start integrating it. So it's important to start off there, and further on, if you go into the operations, training, and this kind of things, it's important to make sure that the operators know what they're doing and that they are using the system as intended. And for all these steps and all these focus points throughout the project lifecycle, simulation is a very important tool to understand what actually and to fix this focus. So in this first phase, if we are able to actually completely simulate and visualize and already put in place the system as it will be developed in the future, then at least we can communicate with our stakeholders about the way it's being operated. What information do we expect from the system? How will it work in the situation where something goes wrong? And how is the user interface? Does it follow the guidelines and the rules that are put in place? So a full simulation and visualization of this phase would be very useful, and that's also what we put into our test and design philosophy. And further on, if you go into the validation, use this simulation actually to simulate the whole system before you start putting it into the on-site. I think everybody read already what's beneath there, so I probably have covered it. So let's move on. This is a very simple system overview, and it's more to show well, in this first phase, when you start thinking about how this system will look like, I mean, you will probably start off with something like, well, we will need a user interface. This one is actually following the guidelines that are put forth by our Dutch Rijkswaterstaat, is putting this kind of to get a uniform look and feel for all these locks in the Netherlands. So you put something together like this, and you start off with a basic system decomposition of all the subsystems and the control system and the user interface that you are going to develop in the next phases. But if you already can simulate all this and put this user interface next to it, we can already start using the system. It's not there yet, but we can already start using it. And this is something we've done. So if we in the next phase, we're getting something like this with all kinds of PLCs and SCADA systems and servers and clients, then we're going into this test phase. We would like to test this. There's no lock yet, but maybe we can make a full functional simulation of all the subsystems that are underneath it and interface with these subsystems. And then we can actually already test our whole control system, our whole user interface towards this functional simulation. And that's actually what we've done. And this is what we call the virtual lock. It's like a virtual C-lock. It's not there yet, but it's in virtual reality, you could say. Which in a nutshell consists of 3 components. One, we have a simulation component, which is a full system model of all the subsystems that are going to be put in place. So all these barriers and these signals and this driving of the doors and the driving of the leveling systems and all this kind of installations. We model these from a functional point of view. Then we have a full visualization, usually based on the building information model, which is mostly a 3D representation of the system to be built. The picture I showed you before was actually also partly from the BIM. And we have for the operation, we build an MME and a video wall. This is like a short overview of the different components that are in this virtual lock. And this visualization actually helps us because it's putting us into a 3D world that shows us immediately what happens if I push a button on this operator screen. So if a door starts moving, how does this look like, and what's the speed of it, and how does the whole sequence of steps that we have to follow by stopping the cars by barriers and signals, and then opening up doors and all this kind of stuff. How does it look like, and how does this work from the operations point of view? And this visualization helps us very much by visualizing this. Well, this is a setup. It looks very casual, and it's actually on purpose because this was in what we call the pre-design phase. We already had a full video wall. This is according to the regulations of Rijkswaterstaat, how a video wall has to look like. And this actually gives us a full view of how a ship will move through this lock. It's not built there, but this is already completely the setup of the operator, which is only starting in 2019. And if we can put this already in place here, then we can at least discuss with everybody and all the stakeholders, what are the good things of this? What are we missing? Is this the video wall or the video layout that follows the rules and is still workable? Because there's always exclusions and things different than what the regulations prescribe. And also, I mean, this user interface, is it really what you want? I mean, is this what you expect to use, although Rijkswaterstaat is prescribing this? Is this really what you want? I mean, is this the user interface as it is intended? And we had a lot of sessions with all the different stakeholders around the table using this system. And you could actually press all the buttons and the ship would move in. You see here, well, I don't have a nice video. I could have put a nice video here, actually. think about now, but that's too late, of course. So the ship would actually move around here, and this operator would have to push all the buttons to start opening up doors and all this kind of things to move the vessel through the lock. Very useful. And we already figured out during this pre-design phase that a lot of the requirements were actually contradicting, and that also our stakeholders were seeing that it was contradicting and were figuring out, okay, how are we going to solve this? And I prefer to do this in the pre-design phase and not when we try to do the acceptance, because then we are a little bit too late. So what I don't have a picture of, but what our next step is, we have at this moment, because this is all software, it's the 3D visualization in Unity, it's built in a game engine actually, because it gives us a lot of performance, which is connected to the simulator, and the operator screen is a custom-built tool which is connecting to the simulator as well. The current setup, what we have our PLC systems, the Siemens S7 systems. There's not that many. I mean, we don't have 20 of these systems standing around. Eventually, that's what I say, it's smaller. And our WinCC OA environment. And we have connected this via the Simba box, or the Simba technology, which is developed by Siemens as well, to our functional simulation, which is providing the full simulation of all the subsystems that are in the lock, and have a sort of like a round trip that the operator can actually start pressing buttons on the WinCC OA environment, the faceplates. This is going through the PLC system, which is then going through the Simba technology into our simulator. And our simulator then actually models or provides the responses that you would expect from the system, taking in consideration all the interconnections between systems, the connection with the water and the environment, what kind of effect this will have. And we'll actually provide the information back via the Simba box into the PLC, and you will see it in the SCADA environment. So we have this whole round-trip engineering where we have a simulation environment connected via Simba to the WinCC OA environment. And this was a very useful exercise for us, because one of the important things in this kind of machines is, and it's probably the same for you all, is that there's a lot of safety as well, of course, involved. So you have to have safety I/O and safety PLCs and this kind of thing. And the Simba box actually provides the gateway to this information as well. So that's how we have it set up at this moment. Of course, I mean, it's not finished yet, but I am very hopeful because we can use these kind of technologies that we have most of the risks that you will see in other projects come up later to have already identified, and by this being able to mitigate these early on and make our project a success. Conclusions and lessons learned. Well, what we have seen is that simulation is very effective to engage the customer and end users early on. This setup, as I showed you, it was for many people very eye-opening. Oh, this is what we expected. This is what we are actually requesting from you to build. It's very good to see this in the early phases because it's not always evident as you would expect to be otherwise, actually. And simulation allows end-to-end testing, so that means that we can actually really go the whole loop and not only on driver and stub level, but really going end-to-end all the way from the operator and all the things that interact with the system and the interactions between the subsystems, and put this back to the end user. And importantly, many things are being designed for happy flow only, and unhappy flow, so to say, if anything fails, and see how the system will handle an unhappy situation. Can also be tested in a very controlled and safe environment. You can do this very early on as well. So you can also, from an operational point of view, get a full set of all the things that you can expect and can see. Well, of course, because I postulate here, so to say, that this will help us to mitigate all these risks and make sure that we have an early acceptance as we expected. But in this case, because it's not delivered yet, we have to still demonstrate it, of course. But I'm full hope, which is, of course, maybe not very solid, but I have a good feeling that this will work and this technology helps us out with this. This was my presentation. Any questions? The customer pays for this. Yes. It depends very much on what kind of price tag you will put on this kind of technologies, of course. That's one thing. And second, this is another kind of contract than what you regularly have because this is design, build, finance, maintain. There's a whole other kind of aspects that are popping up then. So in this case, it was possible, yes. Any more questions? All clear?
I would say, as we are already behind our schedule, may I ask you to come to Mr. Cornelissen during the break or ask the questions on the mobile event service? Sorry for that. But thank you for your presentation.
You're welcome.
I hope we can see this C-Log maybe once it is operational live for ourselves. Now we'll have a short coffee break. It's 3:15, so please be back at 3:45 to start into the next partner presentation. So 30 minutes break, thank you. Before we continue with the customer presentation, I would like to ask Thomas Gottschalk. He has lost his wallet to come to me. Thomas Gottschalk? No? Okay. I have a wallet. No, there are no credit cards inside, sorry. All right. Okay, then, let's continue with our partner presentations. The next one is really very special. We have chosen that presentation because we think it matches perfectly to the Netherlands. Based on WinCC OA and developed by our partner Solid State from the US, the lead developer, Mr. Richard Anderson, will show their solution for the constant harvest hydroponics project. Please see yourself what is behind this very scientific title. Please welcome him on stage.
All right, can you hear me? So now for something completely different than what we saw earlier. I should introduce myself first. I'm actually John Anderson, Richard's taller, better-looking brother. And I work for Solid State Automations Controls. We're out of Houston, Texas. We work in a variety of industries. Obviously, being in Houston, we do a lot of oil and gas, but we make an effort to diversify. And in this case, I think we exceeded even our own expectations. This was a project specifically for a company called Constant Harvest. That's a hydroponics grow facility in the Denver, Colorado area. If you're familiar with recent changes in US laws in the last couple of years, some of the states in the West have legalized the growing and selling of marijuana. And this particular installation is a hydroponics grow house specifically for the growing and distribution of marijuana. Yes. We submitted this one knowing the location of the SCADA days. Specifically a little more on Constant Harvest. Again, they're located in Denver. They started construction back in 2014. And this project had some interesting challenges. They needed to bring up their facility and have it productive from almost day one as they built out as they built out capabilities, it added rooms, and the facility was literally in production as we brought it up. Also, another challenge with this customer was, we heard in these previous presentations about the pre-design and simulation and things like that. There wasn't budget for that sort of thing, and in fact, we never even saw P&ID drawings. When it came time to, we got an email that described there'll be tanks, there'll be X number of tables per tank, each table will have a valve and a handful of other functional requirements. And really the biggest information we got prior to fielding this was a couple of screenshots from a previous system that he had at another grow house that kind of did the things that he wanted to do, and he highlighted a few of them. So our approach to it, knowing that this was going to have to be kind of just-in-time, on-the-fly development and rapid development, and knowing a couple of his other requirements that he asked about, for instance, he had some ideas further out, like mobile UI or tablets for operators within the rooms, things like that. So we quickly sunk up with WinCC OA for this application. And as part of we also happen to do, we have a panel shop, we do build panels, PLC programming and everything else up top to bottom. So we were able to provide a turnkey control system for them on this one. In terms of the PLC interface and the hardware interface, in this case, it's a single 1500 series of 1515 PLC and a series of ET200 remote I/O stations, providing all of the I/O for the various grow rooms and tanks in the facility. As far as the PLC interfaces go, those are doing things like control valves for water to the tables, valves to manage the nutrient tanks. There's actually a pump in each of the nutrient tanks. There's a nutrient tank per room, and there's up to 16 tables in each room. There's control the contactors for the lighting systems, tank level sensors. There's also, now in phase 2, we're implementing some new functionality on humidity control with a misting system, and nutrient batching and a mixing system for a nutrient tank as well that we're adding now. And all of that's integrated directly through the PLC and controlled from the OA interface. Additional interfaces above and beyond from the PLC that are directly to OA were BACnet and Modbus, because it's part of the system and integrating everything. He wanted control of the HVAC system so that he can control his environmental conditions as well. Things like humidity, CO2 levels, and temperature. In addition, like I mentioned before, there was a request, but not much detail on, eventually he would like to have tablets so that the operators, and because it's a facility's fairly large, it's broken down into a bunch of rooms, rather than having to come back in and out of each room to do everything. He wanted the operator to be able to go into a room, control some basic functionality like water a table or change the watering times on a table depending on the status or the water conditions of the plants on a given table or in a given room. So why WinCC OA? I think some of the things I've already talked to that it kind of stood out. Object-oriented capability or design, was a very modular approach that we were able to take. We wanted it to scale so that he could build as he went along and bring things up. So all the way down to the hardware, to the PLC, the cabinets that control each of the tanks in the rooms, those were all done in a very modular fashion and integrated with OA. So when it came time to build out 2 new rooms, by the way, one our remote I/O panel would control 2 tanks or 2 rooms. When he came time to build out 2 more rooms, he would set up, install a panel, we'd bring over the objects, add the data blocks, and it would just start up. And in fact, most of this work, we had some initial on-site to bring up the initial 2 rooms of like a week of work. And since then, all of the development from our side's been remote. We use TeamViewer to remotely log in and add functionality as he's requested it. We haven't had to actually go back on site since our initial visit in early 2015. Another critical one, as I mentioned before, are live changes without bringing the system down due to his approach of bring things up, put them into use as he built and built out. And different things changed. It was some of the functionality changed over time as each of the rooms came up and some additional nutrient tanks. There's an RO filtration system, things were added, and we had to be able to scale and continue to keep his existing rooms in production while we were doing these things. Another fit that was pretty obvious was the communication driver support, as I mentioned before. He wanted control of the HVAC system, simple Modbus sensors for the rooms. So that was fairly obvious match. And then again, tablet support. He mentioned email alerts. A little further out, we haven't gotten to this yet, but there's a doping system he wants to set up for his nutrient tanks to automate that so that he can set up batches of basically what you have to add to the water, the nutrients you basically have to add to the water that you run through the system. Basically, all of the nutrients have to be added to the water as in this growing method. I'm hardly an expert at it, but I've learned much more about it than I ever thought I would know. Through the media, it doesn't have anything. The plants are actually growing in these, to me, it looks like a pot full of pebbles, and you run basically water through them a couple of times a day to keep them moist and to get the nutrients. The water actually runs back to the tank. They recirculate that, and every once in a while they have to purge and refresh the water. To the details of the system, this one I did kind of for the engineers here, for all of us. This is just a quick glance of what we put together for them. Again, going back to rapid design capabilities that OA provides, a lot of this stuff you'll recognize using standard panels and off-the-shelf stuff, and then other things which were quick and easy panels to throw together given standard objects. This whole interface came together very quickly, and we're able to put it together once, and then it scales as he's added tanks. As you can see, the system has, at this point now, he's built out 16 grow rooms or tanks. Each tank has 14 to 16 tables. That's over 225 tables at this point. The system has 8 rooftop AC units and 24 of these baffle VAV units as well that are all tied in that control temperature, which is critical, obviously, with the HID lighting system that generates a lot of heat, but just as critical, things like humidity, and he has to watch the CO2 levels as well, although that has turned out not to be the problem he figured it might be. As it is right now, this is about half of his square footage of the building that he's working in. So he's about halfway through the build. And at this point, he's up to about 1,500 tags to control all of those tables, or all of the rooms, and the tables in the rooms. Of those tags, a little less than half of them are hard I/O, like digital outputs for controlling the solenoid valves and pumps. Actually, the majority of the tags are the various counters and timers. You can see on here, for instance, you're able to set up multiple counters per table. And even within a tank, you have various counters that cause it to do a recycle and switch over to a dump cycle and potentially drain and refill, all based on timer systems that he's able to set up. So the system is full of timers and counters. Over half the tags down at the PLC level used up there. And as far as some of the other features that were easy, kind of drag and drop into the system, he wanted 1 year, he needed trending data for the environment on his room conditions. That was very simple to do. You can see in the slide here that it was just a matter of dragging in a trend chart and populating it to give him the data that he needs, and setting up the archive or the historian using the RIMA database. And as far as other things like alarms, there's approximately 200 alarms in the system. It's not a huge number of alarms. They're all based on things like excessive temperature, CO2 levels, mostly on conditions, tank levels, things like that. It's all pretty simple. I think in one of the previous slides I mentioned, and one of his points of interest is to add the email notifications, SMS. In fact, he's interested in SMS texting. We haven't gotten to that phase yet, but that's likely an additional feature we'll be adding and tying in with his alarms. So I found the presentation earlier on some of the experimenting with texting and the feature there I thought was very cool, and could see already in this case a very direct application for it. And I think that is just about it. Are there any questions? Well, I can lead with a question. One was, because I left it out actually, one was a lessons learned. What were some of the lessons learned in this project? Obviously, for rapid development, rapid prototyping and development, WinCC OA met that requirement. We were able to throw this together very quickly. In the initial 1 week on site, these screens came together very fast. We iterated on them just a couple of times, going through them with the customer, and it's been that way since. The biggest challenge of the project, it turned out, and it sounds like we have people here with experience with building automation. By far the biggest challenge was the BACnet interface, not from a technical standpoint or an OA standpoint. It's really, in this case, the vendor was Train, and to meet BACnet specifications, you have to publish your interface. It's very similar to SNMP in that manner. And yes, they meet the letter of the requirements, and we'll publish all that and give you everything. But in reality, you don't get any sort of sequence of operation information, and it's rarely enough information to do what you want to do. And in this case, being a small customer as he was, he didn't have the sway with Train to get the information we needed to do some of the things he wanted to do. And that's one, definitely in the future when we go to BACnet, HVAC, such control systems, that's something you really want to make sure you have either the information up front from the vendor, or at least you have the push or a position to get that information. In this case, Train actually became a competitor of us in the middle of the project, and walked in and started trying to sell him, their building automation control system in the middle of all of this, which he was totally uninterested in because it didn't tie into the rest of his trending and everything else that he needed. And to work around it, we found a former Train employee who had the software to kind of pull apart what was going on and worked through it and reverse engineered the control system and got it to work to his satisfaction.
So with the data that's getting collected and trended, is any of that being reported back up to the regulatory agencies?
No, there's no requirement there. His need there is purely for, or his desire there is purely for feedback on what's working, what's not. As I mentioned before, there's media there's actually different types of media that they use, and some of them use different amounts of water. There's different plants, obviously, or different strains of plants. Some of them like different levels of humidity at different phases. it's actually I've been impressed talking to him and learning. It's usually through the different features as he's asked for. He wanted to add a humidity control, which sounds simple. We'll just put that in, but no, it's got to be in several phases, and he can set the number of days that it goes, and it goes through that through different growing phases of the plants. It's pretty critical to keep the humidity down to a very tight window, and that changes actually depending on where they are in the growth cycle.
Is he able to escalate growth cycles?
The speed to... Yeah, I assume he is. I haven't asked him directly, but I can tell you he has different, it's not necessarily on a 24-hour cycle. He has options for his lighting and his watering cycles to work over various shorter cycles down to 18 hours, up to 96 or 72 hours. So I'm assuming he's experimenting with that at the least, and what's the nature of that? I haven't gotten the details, but he's certainly playing with those things. And again, the nature of the product lets us, on the fly, give him some different features that he wants to try. He'll literally call me up late in the evening, and he's like, I was working all day today, and I thought of this thing. Can you do this timer and throw that together? And usually the next day, I'm using TeamViewer, connected in, and add a couple of timers, create a new faceplate on a screen for him. As you saw, we use the tabs, and he can test it out very quickly. Anything else? Any other questions?
You talked about OA's ability to scale down as well as up.
Yes. So yeah, this again is an example. Many times we've heard today, and I'm sure we'll hear it more tomorrow, OA is very scalable. And scaling not only means going up, it means going down. As you saw in this system, it has a fair number of tags. It's already up to 1,500, but it's not huge. We don't have redundancy. There's not critical data that requires a redundant server. If the system goes down, it's not like things immediately die. He has options to manually control the system until it comes up. But to be honest, that hasn't been a problem to date. So, all right, anything else?
Thank you.
All right, thank you, everyone.
Thank you, John. So you can see you can use WinCC OA for a lot of different industries. Now we'll have a quick change of the laptop for our last presentation. The last presentation for today is from Siemens Mobility. It's from Renard, Frank, and Jost. And they will show us the engineering tools with WinCC OA through the example of the project CBI. This is a central control system for subway installations. They also show this project at the mini fair, and some of you have the chance to see this project, this reference, tomorrow in the morning and in the afternoon. Enjoy this interesting speech.
Are we shoot? Yes.
We take a little risk to demonstrate you something, but that's for later on. Good afternoon. My name is Renard Cox from Siemens Mobility. Together with Joost Leijster and Frank Mulder, we're representing Siemens Mobility from the Netherlands in this presentation about smart mobility. We look here, we are Siemens in the Netherlands. We are located in the middle of the Netherlands in Zoetermeer, near The Hague. We are contractor or subcontractor for waterways, tunnels, traffic, urban and the interurban area. And we're also center of competence for tunnels within Siemens for Northwestern Europe. We work together with the colleagues from Switzerland and from Germany. We work close together to make nice products. About the organization, my role is I'm responsible for the engineering R&D within our group. We have about 100 engineers, and Joost and Frank are part of the WinCC OA specialist group. Our projects are related to infrastructure, as we saw. This means local control, but also control centers for different types of traffic. Two of the projects who are work in progress, it's on this side. It's the big water barrier in the middle of Holland, we got 3 objects we are renovating at the moment. And for Amsterdam, we are renovating all the train station automation for the subway in Amsterdam. You see a small screenshot on the right side, and tomorrow there's also a site visit possible. But what's the big challenge? What's interesting? The next one. What's interesting? For the subway in Amsterdam, it's 1 line. It's totally new, and we got 5 lines. It's renovation. There are about 120 different typicals, like elevators. They're all different. On the different stations, there are different types of elevators. There's a lot of icons, faceplates, test panels, a lot of documentation. So actually, the biggest challenge is how to structurize and how to organize this information. Maybe one thing to say, like I said, we do projects. We're not selling tools, but we want to inspire you a little bit today. Frank and Joost,
Yes.
you explain a little bit more.
Well, we are in a church, so a live demo should be a success, so we'll do our best. What you want to do today? We want to change our typical life, and we want to show you the tools that we use to implement documentation, test protocols, cross-reference. You will see a lot of stuff happen on the screen. And Renaud will say efficiency, I will say we are just lazy engineers. We don't like stupid work, like making test panels, making documentation. We hate Word, I guess. So we'll show you the alternative. Now, I had some candidates yesterday. I had Helmut and Peter yesterday. Where are they? Not in the room, that's too bad. Okay. Bernard, give me a name, any name. Give me a name. Anna, good name. Martina, can you give me a color? Red, good color. Okay, that should work. Okay, next slide, Joost. You will see the original tools that we made and that we use today. We did make them a little bit bigger for you, and we did translate parts of them, but these are the original tools that we use in our day-to-day business. So let's get started. The starting point for today is the escalator. And you see the icon, which is a relatively simple white or gray icon with a red alarm indicator. And the faceplate shows you some variables, it shows you some commands, some buttons, and some nodes. Today we'll focus on the variables and the commands, and we'll add them to our data model, and we'll then generate all the stuff that is part of this. So let's start. When we began CBI, we decided that it is important to have a generic model for both PLC and for both SCADA. And when you look at our model, when we drill down onto a typical, and for example, the escalator, you will see that our model defines all the variables, all the commands, all the alarms that the PLC guys and the SCADA guys both use. So we both use the same definition. So in all the projects, we would separate. In our current projects, we sit together, we type in the model, and then we generate all kinds of stuff, which you will see. Now, on the screen, you see that we had prepared something called John. Now, we will replace John by Anna, and we will then show you what happens. This database is a web-based database, and eventually we generate an XML file. Now, we're not online, so we did take the file offline, and we can show you. The file is an XML file, and in this file, let's replace John by Anna. And what we're doing now is we are preparing a variable called Anna. We have a command called go Anna, and we have an alarm for Anna. So we change our model, and this model will drive the PLC guys, and it will drive the SCADA guys. And we will show you in a second. So this is our model. We save the model, and then it's time to go to OA. Before Joost starts the GADI, let me tell you that we use the GADI as a container where we add our own tools. So you will see new menu items, new checks, new panels that pop up. Now, when we start the GADI, you will notice 2 new panels. And the first panel that you see is called X-check. And there are a bunch of checks that people normally forget. For example, you start a driver, but you forget all these internal data points. Now, the X-check panel does many, many checks, and it does the checks that you can easily automate. And in this case, you click the Fix button, and it fixes all stuff inside the data point database. So when a colleague tells me to start a driver, I just start the GADI and everything is automatically corrected. The other part is the ASCII files. When my colleague defines an ASCII file called CBI users and he checks it in the repository and I start my laptop, the GADI will say, there's a new ASCII file, it needs to be imported. So all I do in the morning is I start my GADI and this thing always pops up and I just click yes. That's how we work. My colleague checks an ASCII file in, I get the pop-up, I say yes, and that's it. So when we work as a team, it's quite convenient. One guy adds a check or adds a ASCII file, and the others click on the yes button. So fairly simple. Now back to this data model. You'll see the menu item. I keep wanting to point at this TV, which I guess doesn't work, but okay. Looking at the menu item, the first item is basically, well, we call it bestand X in Dutch, but it's called file X in English. And file X gives you a couple of buttons, and basically, let us first generate the PLC source code. Now, you see source code generated for the escalator, elevator, and the slope. We took away most of the typicals to make the story more compact for you. But let's look at the source code for the escalator. And you'll see that hopefully Anna should be in there somewhere. Go, Anna. There's Anna, there's an alarm for Anna, there's a command for Anna. The model is used by the PLC guy and the SCADA guy, and what's important is that we generate his skeleton, but what's even more important, and that's the best lesson that we learned, is that we also tell the PLC guy the values of the elements. We tell him what values the variable Anna has, so he can see that Anna tired is 1, Anna walking is 2, which is fairly important, because it tells the icon developer, he knows what value to visualize, and it tells the PLC developer what needs to be programmed. So the constants seem like a simple thing, but they made a big change to our company, to our business. Back to this panel. Second part, of course, is the data point. And when we look at the escalator, of course, there's nothing in there yet. You see the structure, no Anna. Let's click on the button over here. And the button will correct the difference between the model and the data point. So we don't delete, we only correct the difference between data point and model. Which means that I click this button every morning because it's irrelevant. He only checks for difference and then updates the data point. Now you see variables, you see the alarm, there will also be a command. You don't see the configuration. The model will also contain alarm text, driver definition, archive definition, smoothing definition, data point function definition. So click on the button, and again, this will configure the differences between the model and the database. So again, click the button as much as you want. And now you'll see that Anna has alert config. Anna also has the constants that I just mentioned, tired and walking. So basically, in our project, we have one guy doing the model. He will add the constants, add the text, correct the text, and the other guys in the project team just click the button without knowing what the change was. It's not relevant. Well, a next step would be to visualize this part. Now, before we do, let's first make a nice color. And let's make a happy Martina, I guess. And of course, Martina likes red, so let's pick a nice red color. Why are we making a color? We will make a color and use it in our icon, and you will see that our documentation will automatically contain the new icon with the new color. But also, we will now change the icon of the escalator, and we will add Martina's color to it. But also, our documentation will include a cross-reference. You will see where the Martina color has been used. So we will use the color inside this icon, and documentation will show you where the color has been used, which is great for making changes. In the old projects, you changed the color and you had 20 side effects. Now we know exactly where the color has been used. So here's the icon, fairly simple. Another step would be now to test this icon. Is it working like we expect? Well, we needed 120 test panels, which is a lot of work. But the model allows us to make an automatic test panel. So let's look at the tester, and let's select one of the escalators. And you'll see that we we add the icons automatically. One connected, one badly connected. So you see that the purple cross is working. But also you'll see the Anna variable, and you'll see that that's not Anna, that's the elevator. You see the icon changing based on the variables. So the icon seems to work. But also you'll see that Anna is on the list with the constants that we made in the model. So our programmer doesn't need to know the integer value, he just selects the text, he just selects the word yes, no, up, down. So it makes testing much simpler. You also see here the alarm for Anna. You see that the alarm is raised, and you see that here, you see the red triangle blinking. So the alarm seems to work with the proper text, with the proper integer values. Next step would be the faceplate. If we look at the faceplate right now, there's no Anna yet. When we made the faceplates, we decided that the faceplate should be made by a non-programmer. And that's why we selected a simple ASCII format. And this is our ASCII file. And the nice thing is that you need no programming skills. You just need to say what variable do you want to see. The rest is all done automatically. And because of the model tells us the values, it tells us the text. The model helps us to build the faceplate automatically. So we made the faceplate engine once, and a non-programmer has written all our faceplates, which was a good decision. We had a lot of, it has helped us a lot. Now you see that all that Joost is doing is adding the variable to the list. You can change the order, you can change the text, you can change, you can add some lines, but the whole thing is automatically. And if we save this, we do have to restart the Geddy for this, which Joost is about to do. All this stuff is normally loaded when we start the Geddy. When we now restart, you will see the faceplate live and hopefully looking correct. It does mean that we are able to generate the icons, the test panels, the faceplate fairly fast, without real programming skills. And we'll now see the faceplate, and you see Anna, you see the new button. But also, Joost can now here modify the variable to see the faceplate in action. So he can use the tester to change the value, and he can use the faceplate to see how it looks. Is the text too big? Is the text aligned? Is the text looking correctly? So, well, we made icons, we made faceplates, we did a test of the icon. Looks good. It's time to do documentation, which of course is a lot of work. Yeah? No one likes documentation. And that's why a couple of, I guess 2-3 years ago, we decided to make a tool, and the tool is based on a snapshot. And the snapshot is a scan of the application. It is now scanning PLC source code, it's scanning the source files and parsing them. It is translating panels and parsing the panels. It's scanning the color DB and recognizing colors. It's scanning everything. And it will also, in a second, it will start to make screenshots of the icon and of the faceplates. That's what you see here. And you will see the Anna faceplate in a second. There she is. And the faceplates are up to date because we just made them. And you saw the right icon, the right faceplate in the right bitmap. Now, the snapshot is an XML file. And we can do two things with them. We will generate documentation because that was our goal. But we can also use the snapshot to compare them, to figure out what did we do today. Now, we made one snapshot before this show. And we made one snapshot 10 seconds ago. Now, we can compare them. So right now, snapshot is being loaded. And then a compare is running. And the compare will figure out what was modified, what was changed, and what was added. And the idea is that I send my colleague out into the field, he does his work, he comes back with a snapshot, and then I can figure out what the hell did he do in the field? What did he really modify? Because normally we write it down, but we forget half of it. You know, I did 4 things, but I did 5 actually. So the snapshot compare is like a bonus feature, and you will see the result. And if we now look at the results, of course, we'll see that a color was added. And the color, Martina, has a color component. But you'll also see that we know where the color was used. We know that Martina was used in the escalator icon. And you see, of course, the color components. If we change the color, it would have said old color is red, new color is yellow, etc. So it gives us a nice report of changes. Now, that was the snapshot feature, which is like a bonus feature. Let's do documentation. Again, it's reading the snapshot, so it will load the XML, and it will then produce HTML. And here you see that we have all kinds of categories. You can generate color, documentation, panels, data points, bitmaps, basically everything, and PLC source code, of course. That's why we're here today. And documentation is ready in a second. If we then look at documentation, which is, of course, a normal browser, it's a fairly simple HTML interface. There's no funny JavaScripting. Any device would show it. Let's first look at the color. The color will show you the details of the Matina color, but also it will show you the cross-reference. Where was the color used? And you could click to find the icon. And basically, this tells me if I do change the Matina color, the escalator will be affected, which is great for making a modification. If you look at the escalator, the escalator, of course, is PLC source code, and not all customers like to read PLC source code. And that's why our HTML page, first of all, starts with the icon. And we see the new Matina icon with the Matina color. And we see all the icons that the customer has requested. We see the faceplate. And the customer himself can check the text, the length, the width, the font, all the stuff that he likes. Here, you see that instead of showing PLC source code, we show him a block, because this is a block that he understands. This is what he can read. And also, when you look at, for example, the alarms, you will see that the ANA alarm, it has these values, yes and no, these integers, 1 and 2, it has these alarm classes, and it has this text, tired and walking. So it gives me a complete report about the escalator typical. And in the CBI project, this is the only design document that the customer has received and accepted. This is our design. So we made the decision to not write in Word, but to write in a model and to write in PLC source code and to generate documentation. So no Word, no Excel, but only this HTML. And this is the second project where we delivered this as design documentation. And I think that's a great step forward. Okay, back to the Getty. Yeah, the final step is, we made all this stuff. We made icons, faceplate, we tested, seems okay, documentation. But now the customer wants to see it working. He wants to have a live demo. And for that reason, we made a training system, or Joost made. And I'll ask Joost to show you this button trainer.
Yes, well, this button trainer, or in Dutch knoppentrainer, has been a development that ensures us that we can test our typicals, our software, without the need of any additional hardware. We can skip the PLCs, we can skip the Simba boxes. We do this by software. And also we want the operator that uses this to have a modern look and feel. So he doesn't only know that he is using state-of-the-art software, but he can also see it. An extra benefit of this system is that in the methods we defined, we already pre-made a few with a John variable, which we modified to Anna. Technical details are hidden. They are hidden within these function blocks. Most of us will probably understand the flowchart, so this is quite easy to understand for everyone. So, well, let's modify this program as well. Let's state, for example, that we want the program to wait another second before doing an action. You see, I can drop a block above, I can drop it below. So let's drop it below, and let's tell it to wait a second. Wait a sec. Second, of course. And let's just say 1 second and save. And here we see our new block. So it's actually quite easy for anyone to modify program behavior. Now we still see that John is present in our application. So let's just do this quickly. I'm going to change it to state Anna. And I'm going to say that Anna should go sightseeing. And well, here we got an if-else block with 2 branches, with a true branch and a false branch. And let's check whether she really has gone sightseeing. First, remove the old variable and remove the old formula. And if I go to the variable state Anna, I choose the data point, and I will check whether it's sightseeing. It also provides me the formula. Then I click OK to save, and save again. Now it checks whether she really has gone sightseeing or not. And if she doesn't, well, tell her to go. So let's again modify this to state Anna. And again, tell her to go sightseeing. Well, now we modified this program. We should be able to run it. Well, since we have a very limited screen property over here, we should have a few more screens with our GUI. You can really see the GUI performing all the actions. But if you start running it, you can see that it will run all the blocks, and you will see that it has succeeded and came into the true branch. That's actually our knoppentrainer, or our software, simulation software.
Just to give you an idea, we had an acceptance with the customer some 2 months ago, or? And we showed him knoppentrainer, and the customer said, go away, I can do this. And he sat down, and he started drawing the diagrams instantly. So within 10 minutes, the customer sat down and made his own diagrams, and they liked it, and they loved it. And then they said, because this is for the North-South line, and then they said, I want this for all the lines, this is great. Now, I'm sure you will understand, this is really, I think it looks nice and modern. You see a beautiful flowchart editor, and it's not available in OA. There's no flowchart editor available, unfortunately. So you must understand that an editor like this, of course, requires a lot of C++ code. It's quite difficult to implement. And of course, for something like this, it's easily months of work. It's quite a complex piece of software. And also, yeah, when you look at it, you need a real team of sophisticated people. Yeah. You want to add something, Joost?
Yeah, well, to be honest, there isn't any C++ in this development at all. We only use standard OA functionality. For example, to give it the look and feel of, Windows 10, flat, clean, and have a bit of an office kind of look with a fresh white and blue colors, we mostly use the style sheets. And these tabs, for example, are just standard OA tabs. We just style them. Secondly, it only took me a few weeks to get this up and running. And the things I liked most during developing this, for example, during drawing, I just drag and drop. This is drag and drop OA functionality. And when dropping it, just like I did with the block earlier, that's just add symbol onto a panel. We just created some smart panels, which look like a nice flowchart.
Okay, so this takes us to the conclusion.
Yep.
Kun je terug naar PowerPoint?
Oh, I'm sorry.
Okay, that takes me to the conclusion of this roadshow. Yeah, I think basically it's good to say that tools can really change your life. Some of them were quite big, but some of them were quite simple. And small tools can make a big change. I think that the button trainer showed you that OA can do far more than you think. The button trainer does look like really fancy software, I think, but it is standard style, standard. A lot of creativity, but it is quite standard. So, yes, tooling is a good idea. Think about it, do it, and yeah, as said here, become a smart engineer. I hope you liked the presentation. Thank you, and enjoy Amsterdam.
Thank you, Frank. Thank you very much, Joost. I think what you guys did with OA was just mind-blowing. I hope you agree. It's a really, really great example. I love Frank's creativity on this one. So, many thanks again. By the way, you can also see that again on a mini fair outside, and some of you will have a chance actually to visit the reference live tomorrow by bike. Okay, now it's time for our Q&A session, which actually brings us to the end. So now it depends on you if we stay here for another 1.5 hours or if we are maybe done in 20 minutes, get dressed and get ready for party tonight. However, you might have posted already your questions via the mobile event service, and if you haven't, of course, you can do it now, and also to raise direct questions. Having said that, I would like to welcome again all speakers of today on stage.
And I'm quite sure that Frank should also come to the stage because I think many questions will be around his presentation.
Absolutely. Okay, so let's fire away. Or is everybody really ready for party? Okay, here we go. All right, we have chosen. What is Control++? Question from John DeMay from Michelin.
Yeah, Control is our scripting language that you can use to customize WinCC OA, and Control++ is the object-oriented extension to it that we introduced to you last year. By the way, there's a workshop tomorrow from Todd Malone. Todd, where are you? Somewhere there, yes? Yep. Todd is there on object-oriented panels and a quick start where you will also touch this topic.
Thank you, Elisabeth. So, next question. Notification Bot setzt auf Microsoft. Wie geht's unter Linux? Gute Frage. Wir sind immer bemüht, wirklich Multiplattform zu sein und das auch zu bleiben. Lukas, wie schaut's aus mit Linux?
Danke. An der Stelle geht es, glaube ich, darum...
English.
Confusion.
Sorry. Yeah, the topic would be that maybe I explain the architecture in a short time again. So the notification bot is running in the Azure cloud, and we have an OA connector which is connected to this cloud. That was the manager I stopped when we got this, okay, the plant is disconnected. So the WinCC OA connector, which is running on OA, is in control, so it's Windows and Linux, so it's all fine, it's working. The bot is currently just developed for Azure, so it will not automatically work in Amazon Web Services, but they also have something like there to make this, but currently the prototype and the master thesis is based on the Azure stuff. Yeah, I keep. When Java in 3.15 is going to usable through FAT and web client, I think it's JavaScript means, so the JavaScript widget, and we will bring the JavaScript widget for the FAT client in the patch 3, so with end of May. Then you can use it in a beta version in the FAT client, and then the mobile and the web client. So the web client will also work, but the ULC UX and all that will come a bit later in November, December versions on that part, also the mobile. Can someone?
So, security is a hot topic this year. PCI 7 is certified according to IEC 62443. Are there any plans to certify WinCC OA? Yes. Regarding part 4.1, that's the development process, we would like to reach a certification this year. And regarding part 4.2, we are targeting security level 3 within the next coming years, but we will do a step-by-step approach. I can't tell you a date yet because we're still analyzing the gaps and how we can close them. Martina?
I think there are by now no more questions on our... there's a new one coming in. What kind of authentication exists for operator on devices, like biometry?
Currently for the mobile devices, we think and have tried something on this pass code topic and all this fingerprint, but it's currently not supported. I think there is out of the box, we don't have something like that, but we have already some solutions from customer scene where they have their smart cards or something like that to connect to WinCC OA and then set the user credentials or something like that. There's nothing out of the box. Should I tell something about the technical? Yeah, we've gone through all the questions you have already posted today. So there are a lot of really deep technical questions we thought it's not good to answer here in that round because we really want to take time to answer that in a detail, and we will do that in the next week. We will answer all the questions, and I think like last year we will post the question and the answers on the forum in our portal. Then all can read about these things.
Yeah, two more questions. What is the licensing model for the IoT 2040?
It's a normal WinCC OA server running there, so there is a normal license needed, but I think Bernhard can tell something.
No, we have made some special packages for the NanoBox, and we will do a similar thing for the IoT. But still it's not released. We have some time to think about it. Yeah?
An improvement plan for the GIS viewer is another question.
Currently, I think I know the background of the question. It would be maps or something like that, so Google Maps, so having something like that integrated. Our idea in that part to bring Google Maps or offline maps in that part to WinCC OA would be through the new JavaScript EO. So the idea would be to have Google Maps, or there are some open source libraries where you can load different maps on your device, and then you can set markings or other really nice things. We don't plan to bring Google Maps or something like this to the GIS viewer.
Can you repeat your question shortly? Thank you.
Yeah, I think we can shorten it up. I think that I have seen your name much more than one time on the list, so I think we will have a talk again on that. And we will give an update on that, but currently there is no plan to improve that.
Now you have the microphone, but you're not allowed to say anymore. I have a short question. I was asked by several customers about the positioning of WinCC OA. In my presentation, I talked about focus on infrastructure. And I would ask Bernd to clarify this positioning, because some customers ask me, hey, I'm planning to do food and beverage projects or something in automotive or in manufacturing. I'm allowed to do this, or is this a bad thing?
Yeah, thank you. It's a good question also. I had from a few persons in the break. Basically, that positioning was done a couple of years ago to go with the product management for SCADA systems. And it was done with basically the idea to provide our sales all over the world a kind of basic guideline based on what the products are used in the history, first of all. And that history, well, WinCC OA was mainly infrastructure. And the second thing was, where are the feature sets going to be developed for those various SCADA products? And also here, clearly you can see, and we spoke about already now, just now, we have GIS, we have video. These are typically functionalities which we develop for mainly the infrastructure market, while you have on our other WinCC products, things like scheduler, OEE, line coordinator, which clearly tends toward the manufacturing industry. So having said that, that was given as a guideline for the sales, just to make a kind of basic assumption where the customer is going. The world is much more complex, of course. It depends on, do I have, I'm a very, very loyal Siemens component customer, which uses everything from panel and PLC, and I go to the 1500, and then of course it's very convenient to stay in one engineering system and use the TIA portal. However, this is not graved in stone. It's at the end the customer and his requirements who decide what's the best product out of that portfolio. Yes, and we do have on both sides of the house, We do have projects in China where they do tunnels, because the tunnel in China probably is pretty close to the tunnels in Italy. So if you find a light, you're happy. And that's fine, that's okay. Then when they do it with WinCC version 7. That's totally okay. But also on our side, on OA, we do have projects in the automotive industry. We have OEM customers in food and bev. And again, at the end, it's the specification and the need and the demand of what fits the customer best, who decides what product will be used. So please see that basic positioning as a guideline with regards to the feature set we drive forward, also on our roadmaps. But no, it's not graved in stone. We really listen to our customers. I hope that answers the question for you and for our audience. Okay, some more came in here.
Yeah, I think it's OPC UA. It's fully supported. Yeah, we brought, I think with the version 3.15 or 14, we brought the OPC UA HA, so the historical access to the client. So the only missing link currently, when I'm really right, is the OPC UA HA on the server side. And the idea would be to close this gap. So we will develop this functionality, the HA, as well for the server, and then go to the certification. So from my point of view, yes, all should be fully supported in WinCC OA for the OPC UA server. And will be certified. No. Any plans to develop ICCP protocol? When I Googled that, right? It is this TASE2 protocol, it's the same, and currently, no, there are no plans. We have discussed that some years ago, but it's on the long lists and not on the short list for the next version. Some advice to best practice in experience about working with versioning of frameworks in Linux and SVN?
Yeah, Subversion is supported in the GADI, so you can switch it on. And for more details, I would suggest that you either talk to the trainers tomorrow during the workshop breaks or to one of our consultants.
Yeah, that's a general topic and enhancements planned about GADI, panel designs, and script editor. I think maybe when you have heard that we are doing a usability test about engineering workflows, maybe we have in mind to change something there. It's currently as well not on the short list for the next version. Sorry.
One more question about SIMATIC communication.
What is planned for SIMATIC communication? Planned would be and to announce in a white paper how and what to do and what is exactly to configure so that it is working. We have already tried that, it's working. We just need to make a white paper to explain in detail what to do.
Is it planned to operate or manage snapshots, open another models and only data transfer from SIMATIC to WinCC OA, or maybe another way, from WinCC OA to SIMATIC? What is planned?
My understanding is what was tested together with our Belgium colleagues on a project works in both ways. So I think Brecht is here. He was the guy who did the test. We can have a chat with him afterwards what exactly he tested in which direction. But I think it was bidirectional.
Okay, thank you.
Just see me after the thing and we grab my colleague, my Dutch colleague.
Does somebody want to answer the C# driver question?
Lucas, C# driver question mark?
I'm not sure what the C# driver is. There's a C# API, of course, that is part of our product. And currently we do not support in the product the C# COM-DRV API, if that was the question. I'm not quite sure. It's anonymous, so
does somebody want to precise his question about the C# driver, or is it okay, the answer? Okay. Yeah, I would say we have 10 minutes more or less left. If you have some questions from the auditorium, you can ask them and we can answer them. Or otherwise, we will end here if you have no more questions.
So I see Brecht is here. There was the question if the SIMATIC communication goes actually bidirectional to WinCC OA and also back to SIMATIC.
Yeah, okay. Actually, SIMATIC is an emulator simulator of our PLCs. So it does actually just simulating the I/O, our I/O system on, if you want, also the PLC. So you can have a virtual PLC of Siemens or the real PLC and just simulate the I/O. So the communication is just like a normal PLC and is bidirectional. So what you could do is you make your SCADA system, your PLC program, and then in SIMATIC you make your process. Meaning if it's a lock, then you can say, okay, if the I/O comes to open the lock, we give the feedback that the I/O, that the lock is open. And so you can test fully your SCADA without any simulation in your code of the SCADA or in your PLC.
Thank you, Brecht. It's a standard product available in the FA portfolio. So what is missing is what you said is like just a white paper on how to really configure it in combination with WinCC OA. Okay, thank you again, Brecht. Anything else? Far away? No?
No more questions?
And no question? John, no question? No. Okay, so either everybody's already tired or...
We are here, not really here, but we are here for you the whole evening. So
okay, then I would say thank you to my co-speakers. Thank you to your patience and to all our audience. I think before we leave now, I would like to hand over for a few words regarding the evening program to Martina.
Yeah, we would like to invite you. We would like to invite you to join us to experience an equally exciting but also relaxing trip through the canals of Amsterdam and discover the beauty of Netherlands' capital from a new perspective. We are meeting at 5:45 p.m. in front of the hotel, the Koppelkerk, so at the street, and we will walk together to the embankment pier. It's the Damrak jetty. If some of you don't go with us from the hotel, you come from another hotel, you can go directly, if you like, to the Damrak jetty. If you need help, we have some maps printed out, so you can find your way to the Damrak jetty. The boats will be ready for boarding between 6 and 6:30 p.m. because we have 5 different boats for about 60 people, and they will board once after the other. And yeah, while cruising through Amsterdam, we will enjoy Dutch cheese and wine. And after that, about an hour it will last, we will leave the boat at the Rockin jetty, and we will walk to the Dutch restaurant. We will join dinner together in a typical Dutch restaurant, and at the end of the evening, please feel free to go back to the hotel, to your hotel, or make a round through Amsterdam if you like. It's about 10 minutes walk back from the restaurant to this hotel. Yeah. You all received a t-shirt at the registration yesterday evening or today in the morning, and we would be very happy if you wear it today in the evening. And we are looking forward to spending this evening with you all together. And yes, please be on time at 5:45 p.m. in front of this hotel. And yeah, your very last applause now. Please dedicate to all those who have made this day happen and enjoy the evening with us.
Thank you.